You're in a different spot. Where are you?
Side of the couch.
Haylie, hey, what's your dad's name?
My dad?
Yeah.
Dean?
Okay, who's Seth?
Who's Seth? That's my brother.
Oh, okay.
Why?
Wow.
Who's Ethan?
My other brother.
Okay.
How do you know that?
So on the next door Brickshire neighbor site, somebody was posting about they need some compost spread out, and somebody recommended Seth, and I was like, oh, Baines, I know that last name, and so I figured I'd ask you.
Oh my goodness, that is so funny, dude. Yeah,
Why is that funny?
They post on there all the time. They're like, landscaping, we'll come and do your yard work for you.
Hey, well, I'm getting Lauren Douglas to do some mulching for me once I get my mulch here.
I know, I saw that.
I'm not doing it. Oh yeah, I did say I would help.
Yeah, you said you would help.
Josh is doing that.
Yeah, put Josh to work. Okay, so I just posted it like at 2:01 or 2:02, and sorry for not posting it sooner. So if you want to print it, awesome.
Yeah, I'm printing it right now. Sorry for that.
No, it's my fault because I was trying to make the video without people in it first, because Fuller says she doesn't like people in her videos. But my internet was being so slow.
Kirsten can deal with it. Okay, I'm almost done. Here we go.
No worries. I'm not.
Kevin said he was gonna join, so I'm gonna text him right now.
I'm already here.
Oh.
Oh gosh. She just can't see you because it's just like the top of your head.
Well, I just wasn't
Him
even
and
looking
Gary
at it.
both are all.
Huh?
Lauren, you cut out. But yeah, Gary Bear does the same thing.
Whoa.
Well, I don't have a real great place to put my camera. On my phone.
Are you at a desk or?
I'm in my bed.
How do you write on your bed?
In my bed.
On a binder.
Yeah.
We're almost done.
Haley, why are we always waiting on you?
Kevin, does it look like you have your notes printed out?
I don't need them.
Oh, okay.
You're just gonna wing it?
Yeah.
Miss Mac, you still haven't posted the 4.8.
I know, because I wanted to eat a sandwich.
Honestly, I think it's okay if you don't post the 4.8.
Just do it right now while we're waiting.
Oh, because then I gotta look it up, and it's so complicated. My computer's being so slow, and there's a cat right here. She's like sitting on the keyboard. When are you gonna come get these cats, Lauren Douglas? Oh, she left.
Oh. All right. Look at this. We're ready. It literally took me like, what, 2 minutes?
It's 2:10.
Okay, and cry about it, Kevin.
Haley, I just don't know how I feel about you being in this room. I miss my curtains.
About my room? Kevin, I was taking my test yesterday, and she like messaged me. She's like, "What room is this?" I was crying.
Well, because you've never been in that room before.
Yeah, because I never had a desk in here before.
Not that I mean, yeah, it's just exciting. Okay, so what essentially we're going to do now is we have reached the pinnacle of calculus. So
Oh,
what you didn't? Why?
that's
It's actually not that bad. But this is one of the things that make calculus beautiful, that everyone loves calculus kind of thing. So what we're going to do now is we are going to learn how to find areas under the curve. So we have a practical location here. So we have our car driving 60 miles an hour on a straight highway over a 2-hour period. The graph of your velocity is a horizontal line. Your displacement, meaning how far the car went, can be found by the formula d equals t, or distance equals time. And the area is actually a rectangle. Okay. So what we're going to do is we're going to use rectangles to approximate the area under the curve. Now, this one's nice, right? That's easy. It's not always going to be so pretty. But let's just start by learning how to change our data. So what we're going to do, as soon as it goes to the next page, is we are going to do this problem where they give it velocity. Okay. So our velocity function is d squared. This is our interval. And we are going to create sub-intervals. So pretty much just smaller intervals in the interval from 0 to 8. All right, so if you're thinking about this, if it says 2 sub-intervals, how can you split the numbers from 0 to 8 into 2 equal groups?
0 and 4 to 8.
Yes, no, that's actually perfect. Okay, let's use that number. Say it again, Haley. Kevin wasn't paying attention.
You put in 0 and 4 to 8.
Are we counting 0 to 5?
Yes. So, we're going to do we usually find the area of and here's going to be long. Okay, so next question is like 5 minutes. So next question to this board. What is the length of the interval? Okay. Okay. All right. So the thing that I want to do is to calculate the remember your memory is long outside of the computer. We're famous for 0 plus then you're gonna do okay, so what you guys get so 2 squared, 2 squared, which is
4.
4. Good. And then we're gonna do what?
3 and 6.
Squared, which is
36.
36. Yay! Okay, so now what we're going to take the length multiplied by the other sub-interval and add them together. So 4 times 4 plus 4 times 36.
Whoa.
Did you have one? Oh, look like you're in pain. Do that or not because here, not you. Okay.
160.
160 LD? 160 LD.
I don't know what it is. I just don't have.
Alright, you can try the next one.
Wait, so what is that? Like, I don't understand.
It's only for the object after the table of the
How did that came with that?
So, when you use people, I'll use other people see right? So you can think of it like that. In essence, that what we're going to do is pick up these into smaller chunks, and what it's eventually going to do, it's going to approach the limit of the true value.
So if we did
So what is 1?
If we didn't separate the 2 values, 2 intervals, like we've gotten close. Like if we just did the midpoint was 4.5 squared.
So yeah, it's 4.5.
I don't know.
I don't know where my calculator is.
20.
20.25.
Okay, so yeah, that's not it. Okay, so let's do the next one. See if you
Wait,
what that's how our object was displaced. So we got 60 meters in that time interval.
Oh, okay.
Okay, so now we're just going to use formulas. A big number?
Yeah.
7 is 49.
Oh. What was this for? I forgot.
The length in this case is 2. So you're going to subtract the big number.
Oh, yeah.
No, only 2. You don't have the number. Subtract 2 minus 2. 1 2. My bad. I was trying to make it easier.
Wait, guys, we are. I'm sorry, so don't hate me.
Don't look up.
I'm going to.
So the more we split, the more we get answer.
Yep.
Actually, can I have one?
Wait, 1, 3, 5.
So you have to do hate roll.
How do you know that? How do you know that? You never know that's what we're gonna do. I was making a joke like that's what we're gonna do.
I was wondering how it it's
Oh,
So if it's 0 to 1, the length would be.
okay. It's up.
Working, Haley?
I mean, I'm about to. Where you are, so I'm good.
Okay. All right, so we all see okay, so more. Which can be all time. We just need to see new front of us.
Oh.
Man, it is still raining. Wow. What's wrong?
Nothing. When I don't have that. Yeah.
It's rain.
What do we know?
Oh, we got finished. Everyone was still looking down. Well, except I don't know where you're looking, Kevin.
I finished.
Oh, okay.
You finished. What the?
We just did the same thing 3 times.
What?
I think mine's wrong.
Did you get 170?
Nope.
I did.
I know I was supposed to.
Did you get your midpoints?
Oh. I figured it out.
Yeah, yes, sir. Let's go.
Success?
Huh?
Success?
Yep.
Okay. So as you all notice, the smaller that I break down the subintervals, the closer it's going to get to the actual value. So it's like about 170.7 or so. And this is due to the fact that the smaller the rectangles that we use, the closer it gets to our real area. Okay, so we're gonna do a little bit more practice with dividing up into rectangles with a different example. So pretty much this is just talking about how we find our change in X. This is what Kevin Harris would say more confusing than the actual problem. So let's just go ahead and do the actual problem. Okay, so we have our interval from 1 to 9. And it wants 4 subintervals, and it wants us to find the change in X. So what we're going to do is we are going to subtract 9 minus 1, and then we're going to divide that by 4 to get our subintervals. So 9 minus 1 makes
8.
8, good. And divide that by 4 makes
2.
2. So our length is 2. All right, so we could represent that with our, where's the triangle? Change in x is 2. Okay, so now we are going to list the coordinates. So we are starting with what number?
1.
1.
Good. So the first term equals 1, and to find the second term, what are we going to add to this?
2.
2, good. Yay, which is 3, which means our second term is
3.
3. And then guess what we're going to do again?
Add 2.
Add 2, yay. Oops. 5.
What's the point of this?
We're finding our intervals. Just
Oh.
showing you a different way to do it.
Why does it start with 0? Why doesn't it start with 1?
Because that means that's like my initial value.
1 would be better.
And is it measured in like seconds or minutes or like what?
Well, this is just numbers.
What is the interval of?
We don't have enough information to answer that question. This is just numbers.
And why does it go all the way to 4? We don't have an x4.
What do you mean we don't have an x4? We have an x4, it's 9. It's the end of the third one. So you're just not going to add anything to it. So you're going to say x4 equals 9. You're just, that's it.
Oh, I did not do all this. X of 0 is 1. How?
Yes, x of 0 is
We'll do
1.
the midpoint thing too.
No, we're not doing that for this one.
Tough.
Hold on.
What are you eating? Chocolate?
More of them. Oh.
So, okay. So we're done?
Well, this, yeah. All right, now we're going to learn something new.
Wait, what would be the nth? Oh, never mind.
So we could write it as 1, 3, 3, 5, 5, 7, 7, 9.
Yeah.
Huh?
Those are just like
Oh, yeah. That's what I did first.
dub.
Okay, so
Dub.
keyword.
What?
Left, you're going to use the left endpoint. Right, you're going to use the right endpoint, and then midpoint, you're going to use your midpoint. Okay?
That makes sense.
So it makes sense or it doesn't make sense?
It does.
It does make sense.
Okay. So here's a picture of what this looks like. You will have to draw this picture in exact detail, replica, on your next test.
Psych.
Okay, so pretty much left means you're going to use the left endpoint to make your rectangle. So that's this point for each of these. Boom, boom, boom. The right uses the right, like this, to make the rectangles, and then the midpoint makes a rectangle from the midpoint, like that. Okay.
Oh. Okay.
Why does it matter?
Oh, yeah. Kevin Harris, you are so on point today.
Mm-hmm.
Okay, so it matters, and we're gonna see why it matters, Kevin Harris, in a second.
But the midpoint one is like the most accurate. So
oh my
gosh,
seriously. We're doing it anyway. I don't care what you say.
Okay.
All right. So we are using our graph of sine x, okay? And we're going from between 0 and pi over 2. Okay, so the first thing that we're going to do is we're gonna find our length. So to do that, we are going to subtract pi over 2. Keep forgetting pi is under Greek.
0 divided by 2.
So pi over
Wait.
2 minus 0, which is going to be pi over 2, right?
Why are we subtracting 0? Because
All over 2.
Because if it didn't start at 0, this would make a difference.
But what are we finding?
We are trying to find the length of our subintervals. So how many
So it's
subintervals
pi
are
over-
we making?
6.
6. So we're going to take this pi over 2 and divide it by 6.
Yeah, well, that's
Oh,
divided by
like-
2, though.
Say what, Lauren Douglas?
So that's when we're finding the length.
Yeah, we're finding the length.
So then
That's
why
gonna give
did?
me-
Oh.
What's up, Haley?
No, I was silly. Just a mistake.
Oh, okay. So for this, I got pi over 12 for my length. Agree?
Yep.
Okay, so what does that tell me? That tells me we're going to make a chart and we're going to use this for the next 3 examples to reference. Okay, so we're going to have our left value, going to have our right value, and we're going to have our midpoint. Okay, so we are going to start with x sub 0, Lauren's favorite. Okay, so where are we starting this? Where are we starting this progression at?
0.
0, good. So the first left term is going to be 0. How are we going to get the right term that goes with that one?
Add pi over 2.
Add.
Add pi over 12, good, which in this case is going to be
Pi over 12.
pi over 12. Okay, then for x sub 1, we are going to start with what?
Pi over 12.
Pi over 12, good. All right, so I'm going to let you guys go work ahead because you'll probably work faster than me because I'm typing and not drawing.
How many are we finding though? 6 up
We
to
are, yeah.
Okay.
I love it when you ask me questions and then you answer your question.
It's my bad.
No, I mean, I was being serious.
Three pi over 12.
Oh, man.
What's wrong?
Oops. Oh. And you want us to end with x sub 6, right?
Mm-hmm.
Right?
Yep.
So do we leave it as like?
Pi over 2.
Do we add?
Pi over 12.
Do we add what?
Oh, never mind. Okay.
Do you want us to find the midpoints?
Yeah, go ahead, LD.
Yikes, dude.
Why yikes?
I don't have room for all this.
Well, it goes with the next example, so you
Sorry.
could make it smushy.
Oh, okay. Why are we putting this under left?
Well, because we're going to need all of them. So I figured it made sense to make the chart and then just reference it. Is it upsetting you? Looks like it's upsetting you.
No, I just what is, I don't understand how it's under left.
It's not. We need left for left, we need right for right, but you have to find the right value in order to get the next left value.
Matt.
Yeah, Lauren Douglas?
I don't.
You asking me a question?
Well, for the right one for x5 is supposed to be 5 pi over 12. I don't know. I'm confused.
I am confused as well.
Because I didn't do that, but I don't know what we did different.
Wait, what'd you get?
Oh, I skipped x3. That's why.
I'm just confused in general. I don't know how you're getting the right.
Adding pi over 12.
Adding 0 plus pi over 12, which is pi over 12. Then you start with pi over 12,
Oh, okay.
add another pi over 12.
Oh, okay. Right. That makes more sense.
Okay.
Right. And I forgot how to find our midpoint again. No, I did not. It's like,
Midpoint is tough.
I think it's easier if you use what you got for the right term before you reduce it.
Yeah, it probably would be.
so midpoint will be right here. We'll just rewrite this. We get
And I didn't reduce these. I just left them. So don't freak out if yours are reduced. Just because if you don't reduce them, you can see a pattern. Do you see the pattern?
Yep.
Okay, bam. All right, did you guys get the same answers?
Yeah.
Yeah.
I mean, yeah, but I just didn't solve through all those. 5 pi over 24.
Okay, so what we're gonna do now is we are actually going to calculate the left value. So we're gonna do the same thing like we did in the previous example where we're essentially doing the length times the value that we got when we substituted in our answer. So we're just gonna write a more simplified form of this so that we don't have to keep writing everything out. So what you're gonna start with is, I don't know why that's all the way up there. I'm gonna start by writing my pi over 12 on the outside of a parentheses. That way I don't have to write it like pi over 12 times the sign of 0, pi over 12 times the sign of pi over 12, pi over 12 times, so I don't have to do all that, all right? So what we are going to write on the inside of the parentheses is the value of our function. In this case, it's sine x, when we plug in 0 for x, when we plug in pi over 12. So we're gonna go through these first 5 terms here. Okay, so from x0 to x5. We're not including x6, all right? So you're going to say the function when you plug in 0 plus the function when you plug in pi over 12 plus.
Why are you multiplying it by pi over 12 though?
So I don't have to multiply each individual one like we did. Well, we didn't do it before because we did the midpoints. But so you're multiplying the length pi over 12 by each one of these terms. And so rather than do it individually, I'm just doing it all at the end. So
It's gonna be a lot of calculator.
yes, you are using your calculator.
Last time, didn't we do it with the midpoint squared?
We did with the midpoint, yes. But this is a different function now. We're using sin x. And we're not using the midpoints this time. We are using the left bound. So we're using these 5 x values. Well, it's technically 6 x values.
Yikes. Okay.
Yes, but a lot of calculator, as Kevin said. Okay. Pi over 6.
No way.
What?
I was halfway through adding them and I messed up.
Oh, it'll be okay. All right, when you finish, look up because I put my answer on the board. What's that one's name? Pickle? Pickle's next to you, Lauren Douglas?
Oh,
All right, if you got it right, guess what you're gonna do?
do it from the right side.
Yes! Man, Kevin Harris, you must have eaten your bran flakes. All right, so you're gonna do the same thing, but you're gonna do the right side. So Lauren, this is on the next slide for you because I know you messed up your example that one time. All right, and while you guys are doing that, I'm gonna run to the bathroom.
No way.
All right, did we get a right answer?
I don't know what you got.
I got 1.125.
Yep, I got that.
The ladies are both muted, so I'm not sure if they got it or not.
I'm almost done.
Miss Mac, were you talking to me when you said that, Pickle?
Yeah,
How can you see her?
she, like her ears were in the corner, or he, she, he.
Oh, crap. Yeah. No, well, she can hear you now. Look
You
at
got 1.125? Yes, sir. Let's go.
Hello, little pickle.
She's so sweet. Now she wants
Pickle, do you want to meet your new sister? Look, it's Chloe.
Oh, she ran because my mom opened the door.
Okay, so as Haley ruined our fun before, so this is a picture of our left, right? And this is a picture of the right. So the left, when we use the left endpoint, that is going to underestimate our area. And when we use the right point, that is going to overestimate our area. Okay, so then we're going to do this one more time, and we're going to do it using our midpoints. Kevin, do you need me to go back to the midpoint screen?
Oh, no.
Oh, okay. But did you have another question?
Yeah, what'd you get when you did the midpoint?
What did I get? 1.003.
Dub.
Wait, Miss Mac, for the right under the picture, did you say it overestimates
Yes,
the area?
The right.
the right overestimates, the
I
left
really get that, but
underestimates.
sure. Why not?
What'd you say, Kevin? How do we
I don't
actually
understand that, but
find the true area?
no, like, why does the left underestimate it?
Oh, because if you look at where the rectangles are, you have these gaps of white that is not being taken into account. But then if you look at the right, it's going over the line here. So it's adding extra pieces that are not relevant for the true area. But then if you look at the midpoint picture, even though it kind of goes over, this triangle looks like I could flip it over and kind of put him right here.
Yeah.
Hey, Kevin.
Huh.
Josh said, hey.
I said hello.
He said,
Is Josh there?
he's on FaceTime. He just called me.
Tell him I
say
said
hey, Miss
hello.
Mac? Do you
Yeah,
hear
tell
you?
him I said hello.
Hello.
Hey, I showed Lauren all the mulching that you're gonna have to do.
That who's gonna do? We're gonna do?
She said you're gonna do it, not her.
We as a team.
Yeah, see, I like the way that you think. All right, so I want you guys to try this one, but you don't have to try it right now. You can try it later, but I'm gonna give you the answer for the left and the right.
Hold up, man.
What'd you say, Kevin Ayers?
What the heck is that?
What the heck is that?
Yeah.
It's a table of values.
Oh, like the one we created?
Yeah. So
Wait.
when you're doing the left one, you're gonna focus on the first 4 numbers. So for left, you're going to do this. And then for right, you're going to focus on the last 4 numbers. And that comes into play because if you were to write these as intervals, you could easier see which one's on the right and which one's on the left. Does that make sense?
Nope.
No? Okay, so like,
Nope.
Wait,
not
so
at
the
all.
dots? What? Why
so
did this
if I
highlight?
were to write this, the first number is 0, right?
Mm-hmm.
And then the
Uh-huh.
second number on that interval is 0.5. And then the first number on the second interval is 0.5. And then the second number is 1.
Oh, I see what you did.
So that's why I like color coded it so you could see, because the first 4 numbers are going to be in the left interval and the second set, well, it's not really a second set of 4. But I want you guys to try that, but not right now, because I want to
So
finish
wait,
this. Unless you really want to.
So what is the f of x thing? Why do we care about that?
That is the value of the function when you plug in the x value. So they gave you the answer kind of like when we did the last problem, we had to do like sine of pi over 12, sine of pi over 3, sine of pi over
Oh, that's
whatever.
tough.
They already gave you all
We
of
would just
that
do
work.
We would just do 0.5 times the number.
Yeah,
Oh, times like 1 times 3 or whatever. Okay.
How do you get 7 for the left then?
1/2, because that is my length, times the value of the function at 0, which is 1 plus 3 plus 4.5 plus 5.5.
Wait,
Yeah.
1/2 times 0 times 1?
Yeah, 0.5 is the one. I forgot about that.
So you are using the value of, okay, so you're with me with the fact that the length is 1/2, right?
Yes, you put that out in front, and so it'll
Yep.
be
So then I'm
0
going to do
times
the
1.
no. You're not multiplying those 2 numbers together. You're doing the value of the function when x is 0 plus the value of the function when x is 0.5 plus the value of the function when x is 1 plus the value of the function when x is 1.5.
Then why do we care about the f of x?
Because what is the value
Oh,
of the
that's what
function
that
when x is 0? It's 1. So you're
1/2 times 1. 3
1
plus
plus
4.5 plus 5.5.
yes.
Okay.
All right. Do you guys want to do the other one real quick since you already did the first one?
No.
No?
Yeah.
No.
Oh,
Nope.
oh, well.
Well, Kevin, you're the tiebreaker.
We don't have to.
Did he say yes or no?
Nah.
Okay. Okay, so you learned this in pre-calc and I think algebra 2. Did you guys do this in
Oh my
algebra 2?
gosh.
Yes?
Yes.
No? Okay. So it's a way that we can write our sums in a more compact way. So we have a few properties. You can take out your constant if you have it. You can split them up into 2 separate things if you're doing addition or subtraction. And then we got these. These are a game changer. Like, super awesome, because we're going to need this for our very last example. Okay, so throwback to pre-calc. Do you remember the formula to turn these into sigma notation? Probably not, if I had to guess.
Don't even know what this is.
Okay, so what we're going to do is the rule is it's a sub n, where n stands for like some number, and
Like
it
A plus N or
equals,
something?
say one more time, Kevin.
Isn't like equal like A plus N or something?
Yes, you were so close. You were so close. All right, so, oh, I didn't mean to make those all be small. All right, so plus D stands for the difference.
Oh,
And then n minus 1.
I remember that.
Yeah, I mean, I did it last semester and I had to look it up. I was like, what? I don't remember this.
I must have been absent when we were learning this or something.
You think so? Well, you had pre-calc when
Yep.
Miss Kelso was pregnant, right? So.
Yep.
Yep.
Okay, so A1 stands for your first term. So in this case, it's 4. So we're going to say 4 plus D stands for the difference between the numbers. So in this case, I want you to look at the second number, which is 9. 9 subtract what gives you 4?
5.
5. And I always like to check the next one. Is 14 subtract 5, 9?
Yeah.
Yeah. Okay.
Yeah.
Just to make sure, because you know sometimes I'll get a little excited with my subtraction. All right, now simplify this out.
Are we trying to find the fourth one now?
The fourth one? No.
What are you
I'm trying to
solving
write
for? Like
the
for
generic like equation that I could plug in like 4 or 6 and get the answer. Okay, so my generic equation is going to be 5n minus 1. So do I have a sigma thing in here?
Yep.
No, I mean, I meant, is there one on here? Not, I'm pretty sure there is one, but I don't know.
So this doesn't really have anything to do
yes.
with what we just learned, right?
Yes and no. I mean, they're related, but it's more is going to come. We are just like starting this section. How can I make this bigger? Can I make this bigger? I don't feel like it's getting bigger. Do you feel like it's getting bigger? I don't think it's
No, just keep going. You're good.
Okay. So our equation is 5n minus 1. See, just the text is getting bigger. So now what we need to do is we need to find where it starts and where it ends. So what you're going to do to find where it starts is you are going to equal this equation to the first number that we had. So the first number that we had was 4. So you're going to say 5n minus 1 equals 4.
1.
1?
Whoa, good job, Kevin.
Okay. Okay.
Okay, so guess what we also need to find?
Where it ends.
What?
Where it ends, LD. What do you think we're going to do?
That equals 44.
Yes.
Equals 9.
No, LD doesn't sound confident.
It is.
Okay.
Yeah.
All right, good. So it looks like that one we're all done. Bam.
Whoa.
All right, you guys in the next one.
Oh.
So wait, so n equals 9 goes on top.
Yep.
That was crazy.
Why does n equal 9 on top?
Because that is the last number that I get, and that gives me 44 for my answer.
Oh.
So you put the last one on top?
Yeah, last one on top, first one at the bottom.
Makes no sense.
It makes no sense? Okay. Oh, Kevin, do I need to go to the next one so you can actually see it? Yeah, probably.
No.
Why, you're just not
I
going
have
to do
the
it?
notes pulled up.
Okay. Okay.
All right, here we go.
Do you want us to do the next one too? Oh, the next one's different.
Then, yeah, the next one's
Oh, I
different,
forgot the
so
one. My gosh.
don't start it yet. Do you need me to go back, Kevin?
No, I have it written down.
Oh, okay. Good job.
It's fun drawing these little things.
I am horrible at it.
I'm not good at it, but it's just fun.
I wouldn't say fun.
Okay. Well,
Kevin Harris, you're always being like a negative Nancy.
Kevin only has fun when he plays basketball. That's it. Miss Mac,
Haley,
are you grading our like 4.5 through 4.7 homework?
like, what do you mean? You know, actually, can I ask
Like-
you guys something?
Yep.
So,
Okay, so you know how like you guys do your homework and stuff, and I haven't been like grading it really. I was thinking that so like let's say you did 4.1 homework through 4.3 homework, and you turn them in, and usually I just put like a check on Power School, which I haven't done anything on Power School for calculus. But would you be okay with it if I still did the check thing, because I need that to keep me organized with who did what, but if you turn everything in, giving you 100 for a classwork grade for that set of stuff? Because I feel like we need some classwork
That's tempting,
grades
Miss
to
Max, but that means I have to go and do all 4.5 through 4.7 homework.
You haven't done any of them?
I've done 4.5.
I mean, I did not do those, no, because I took the test and I did the review and I thought I'd be fine without doing it.
Oh, okay. Okay. It was just a
How
thought.
about
I mean,
how about the ones we turn in? We get 100 classwork for.
Well, I don't want to put them like all in as an individual thing. I was trying to make it easier for me.
no, like, yeah, like why don't you do both? Like what Kevin's saying, and like if we do our homework, we can get the grade, and if not, then,
Exactly.
like, do this like sections, like you said. Because I've done all my other homework, just not those 3.
Wow.
So
I
like,
should
then
like,
it's like, we
I
don't
should
want
like
to.
call your mom or something.
My mom actually gets mad at me for how much homework I do. Not even lying.
I hope we get graded because I've been doing them and I don't enjoy most of them.
Okay.
So if we do it,
Are we done with this one?
yeah.
Well, Ms. Mac, whatever you decide, just let us know so I can decide if I'm doing my homework or not for those last ones.
I say we just start it now. If we're gonna do it.
And go and do blah,
Oh no,
blah,
I've done a
blah.
lot of other homework though.
Yeah. So
Yeah,
I just feel like I want you guys to get points for it.
Yeah, if you submit, you get 100. If not, it's exempt.
No, but Kevin, we gotta not be biased here. Miss Mac, that's a good choice. Dang.
A good choice.
Okay, I'll
I'm
do my
biased.
homework.
Did you
You just
guys
don't want to
get
do your homework, Kevin.
5n minus 2?
And make it like extra credit. Extra credit.
5n minus 2, yep.
Okay. And where did you guys start?
So that equal to 3.
113.
N minus, yeah, n equals 3.
N equals 3 was where you started?
1 equals 1.
Hey, what are you
N equals
talking
1.
Oh,
We just set the equation equal to 3.
yeah, I thought you were asking like what we did to start.
Oh no, I'm sorry.
Yeah, that's
I
right.
just wanted the answer. All right, where do you end?
N equals 13.
Good. Beautiful. Okay, yay. All right, now that we have that,
Yep.
let's do one more example. 2 more examples?
We can really just
Face
Yeah.
down. Oh,
All right, well, the first one's easy, right?
yeah, sure.
What are you supposed to do?
Oh, LD. You bring me so much
It's
joy.
just about- Evaluate.
Let's just do 1 to 3.
Yeah.
Okay.
So you're going to start by plugging in 1. And this is supposed to say dividing. I don't know where the bar went.
Still there.
That's it?
Yeah, this is it.
This is calculus?
This is, yes. Divided by 3.
Oh. So
Why'd
what?
you plug in a 10?
Because I don't know.
Oh.
I need to move this bar out of the way. Oh my God.
What are those bars doing?
I was just trying to organize it, okay? I don't know.
Just tell us to plug in 1 to 3 and then.
Yeah, plug in 1 to 3 and add them together. Okay.
And add them together.
Add them together.
Oh.
Why do we add them
Because
together?
this symbol means summation, which means you add all the
Yeah.
thingies.
14 minutes.
Do you want us to do the last one?
Do we get 4?
No, well, I mean, you could try to do the last one, but I would be like, that's like, there's an easier way to do it than doing all the numbers. I didn't hear what you said. No. All right, did we get this answer?
Is it 6?
I got 6. Did you get 6?
4. What?
You got 4?
What?
What?
Hold up.
You got 4?
Okay. It's over 3. 2 times 1 plus 2 is 4 over 3.
Good.
And then you get 2 times 3 plus 2, which is 2 times 3 is 6, plus 2 is 8. So you get 8 over 3.
Okay, what about 2? You
And
didn't
you add them
do 2.
together.
You have to do 1, 2,
I
and
didn't know
3.
we plug in 2. Oh. So then you get 4, 6 over 3 is 2. Okay. So 4 thirds plus
How did I add that wrong?
6 thirds plus 8 thirds.
There you go.
Equals 22 over what?
6 thirds is
2.
2.
And then 18,
Oh.
15, 6 thirds is, yeah. You have to add them all together. 18 over 3 is 6. Yeah. There we go. I got it.
Okay. Well, I'm a little nervous for this next one then. So first, we're gonna split this up. Split
What?
it up. Okay, so I'm gonna try to write this with the pen, but it's not gonna work so good, so. Okay, so you're gonna have your summation thingy, right? You're gonna put the 2 on the outside because we can bring the 2 to the outside. And then we're just gonna have the P on the inside. This is still gonna say 1 and this is still gonna be 10. Okay?
Oh my God.
Then we're gonna write our plus. Then we're gonna have our second summation thing, P squared. Starting at 1, going to 10.
These are terrible.
I don't know what you. Oh, that's one of the.
We
Yes,
do all
it's one of
those?
the,
No
the
way.
things.
No
You could
way.
just split the 2 pieces up and you can take 2 since it's a constant out in front. Okay, so now what you could do is you could plug in 1, then plug in 2, then plug in 3, then plug in 4. Do you see how this is annoying?
Mm-hmm.
Okay,
Yep.
so
Yeah.
instead, we are going to look back to these rules right here. And so what this is telling me, Chloe, get off my papers, is that since I have just a value for the first one, what I can do to go faster is plug in my top limit times my top limit plus 1, all divided by 2. So that's what I'm going to do for the first one. 2 is still going to stay on the outside.
Bet.
And then we're going to say 10 times 10 plus 1
Over how much?
over 2.
Over 2. The 2's just cancel out, don't they?
Yes.
1100
So 100
or
plus.
110?
110. Good job.
Yep.
Okay,
Wait, what?
now 110.
Oh.
That's the answer for the first one?
That's the answer for this first part right here. Now we have to do this second part. So do we want to do all that work? No, we don't. We want to use another rule. So when I have a squared, what you're going to do is you're going to take your top value, multiply it by your top value plus 1, multiplied by 2 times your top value plus 1, all divided by 6.
2 times top value
6.
plus 1 all over 6. Okay.
6.
So it'd be 11. Wait.
So first 10 times 11, because 10 plus 1.
And 20 all over 6, which is 220.
770?
I got 385.
Not the 2
What?
in front.
2 times.
Oh, the 2 is
The 2 only goes with this, and the 2 canceled out from this.
Yeah.
Wait, but you just.
You got 385?
I got 385 for
How did you
this
get
part
21? Oh, 20.
I got 385.
because in the formula, Haley, it's 10 times 10 plus 1 times 2 times 10 plus 1. So 10 times 11
Oh,
21.
Okay, so 2 times 10 plus 21, so that's 21. So 110 plus.
Times.
No, it's plus. Not times, Kevin Harris.
Hold on.
Hold on, man. Do some more.
10 times 11 times 20. How?
How what?
Wait, can you go back to the formula, please?
Yeah, I'm so lost how you did this.
Go back to the formula for 1 second, please.
This one?
Yeah.
Yeah, so what is the formula? It's n times n plus 1.
So 10
10
times 11.
Times
1 times
10 plus 1,
all
11.
over 6.
Times
11
2 plus
Times
10
21.
is 21, all divided by 6.
times 21.
Yeah.
All over.
So 10
So you
times 21 divided by 6. 385.
Yeah, that's 385, and then you're
So why
going
are
to
you
add that
adding-
to the 110.
For what?
10 times 21.
For what, Kevin Harris?
Why are you adding it?
Because
Yeah.
originally they were together, so I have to add this part and
Oh. Yeah, you gotta tell us.
Divided by 6. You get 385, right?
Good job, Haley.
Okay.
Dub.
I'm getting there. Just wait.
Yep.
So then you add them together. So 110 plus 385 equals 495, dude. Let's go. That's my whole answer, right?
Yay! We're all done. Woo!
Sick.
So did you guys have fun? Was this fun? Is this
I
better than
like
the
the end of.
videos?
Yes.
Miss,
This isn't hard. It's just time
let me
consuming.
or let us know what you're gonna do about homeworks, because I don't want to keep doing them if they're not gonna be graded.
I think I'm gonna grade them.
Um,
I think I'm
do
gonna
not
put in.
grade the
I think-
4.5, 4.6, and 4.7.
Yeah.
Besides Lauren, give Lauren the credit.
I'll have to think about it. I don't want to say. I don't
Well,
want to
that's-
commit to an answer right now.
Alright.
Okay. Well, I'll do 4.5, but.
I mean,
Oh, just
4.7 is
next minute.
easy.
Just wait.
But yeah,
Yeah,
don't.
I mean,
work on the current. Work on the more current stuff, and then because I mean, I haven't even graded your pirate scavenger hunt. Like that's how behind I am on grading.
Yikes.
Do you think that we would have that stuff in before we decide if we want our letter grade?
I hope so. That's like a month from now. Yeah, I should be able to.
Well, yeah.
I should be able to. I just, it's been
Alright.
challenging. It's just been challenging.
Yeah, I feel that.
And I don't have any more student involvements to do all my work. LD.
All right, well, bye.
Okay, bye,
I'll
Kevin
see you
Harris.
later.
Have a good day.
Bye.
All right, bye, Miss Mac.
Bye, Lauren.
Don't forget to put the 4.8.
Yes,
Drop
I
off.
shall do that right now.
Okay. See
Okay.
you guys.
Okay, bye.
Bye.
And I sent you the text reminding you I'm taking stats tonight, and
Instead of calc. Okay,
I'm gonna
All right.
take calc tomorrow.
perfect.
All right.
You're the best.
Bye.
Bye.
Hmm.